So lately, I've been getting a lot of questions from students about, the future of art, working as an artist in the game industry, how it affects AI and getting a job and stuff. And I feel like one of the careers that's going to be most in demand is really being a tech artist, is which I do now for Netflix. And so I want to create a series that kind of goes over the entire art pipeline because that's what a tech artist really does. They go in there, they fix bugs, they create shaders and things like that. So I'm going to start the whole series just on making shaders. And today we're going to take a look at how to use a small bit of HLSL code inside of ShaderGraph, and we're going to use a custom function node. And we'll make it super simple, and it's just going to affect like a color that's changed based on the object's world position using HLSL. And the reason why I'm doing not just ShaderGraph, but a mix of both is because I feel that the skills of knowing HLSL opens up doors and it unlocks really cool features and makes some really cool stuff. So anyway, right now I have an old project. You should just make a new URP 3D project. And I'm just using this project that's here. But a lot of it's going to be, custom stuff. So I'm just going to right click and create a folder here and just call this like, you know, fun with shaders. And yeah, let's begin. Let's start with creating our first shader graph. So I'm going to right click on fun with shaders, create. I'm going to go to shader graph here and I'm going to choose a URP shader and a lit shader graph. And let's name this custom world color. And what you'll notice is right off the bat, it creates this, this shader. And then in our inspector here, and if you want the same layout I have, just go to 2x3 and then you can adjust the look of it. Here, we'll do that together, but 2x3. And then I'm going to grab my project docket down there. And what I normally do to save space, especially if you're on a laptop and you're following along with this, is I click the three dots and I go to one column layout here. Now, we want to create a material to work with this. So we're going to need a game object to attach this material to. So we're going to create two of them, actually. We're going to create a 3D object, which is a plane. And by default, you can see that there's a material that's attached to this, and it's standard URP lit material. And we want to make sure that this is at 0, 0, 0 in our world. The next thing I'm going to do is go to game object, 3D object here, and I'm going to create a sphere. Again, it's 0, 0, 0, but I'm going to have to focus on this and just kind of move it above my line here. And I'm going to be talking about my hotkeys and stuff because I am assuming that this is still a little bit of a beginner tutorial. So we have our sphere in our scene, and the way that shaders affect the surface properties of our model. So we can use a vector, have it affect the vertices in there by using some sort of vector feature that'll make like a wave, things like that. We're going to start off by creating one of the most universally used ones, which is essentially later we'll move, like the next video, we're going to work on an outline shader with a toon shader attached to it. And that's kind of, like you see in Breath of the Wild and stuff. But anyway, so I'm going to right click on this custom world color and I'm just going to create a material here. And then I'm just going to grab this material, just drop it on my sphere. So here's my sphere. For some reason, I named it F by accident, but let's call it ball just for fun. Now you could see that automatically in our shader graphs folder here, let's go back. We have a new shader in here and it's called custom world color. Now it doesn't have any properties, right? Like it's just gray. And we can add properties to this. So let's go ahead and hit edit. And I'm going to just double click on this custom world color. And you can see here that at the top, there's these different parameters: position, normal, tangents, which affect the vertices of our model. And there's fragment, which really just affects the sheen or the look of our model. So let's go ahead and create our first custom function, right? So I'm going to right click in here. I'm going to go to create node, and I'm just going to type the word custom. Now, what a custom function allows you to do, and these are probably the most scary for most people, is the custom function is where we can inject HLSL inside of a shader graph. And again, this is super powerful. It's something that you need to get used to and comfortable with if you're going to write advanced shaders or if you want to work on a AAA game. You can get away with some stuff using shader graph, like you can make a toon shader, things like that. But to get real control or real of what your actual shader or the look of your model, you're going to have to learn how to create some HLSL. Actually, let's take a step back here for a second. What we're going to create in this video is we want to make a shader that changes color depending on where the object is in the world, right? And as I stated, this is a pretty good way to kind of look at where our object lives, right? Like as we're moving it around the world, how we can get world position. So let's go ahead and create a position node. So I'm going to right click, go to create node. I'm just going to type position. Now, we're going to set its space here to world. So what is this going to do? Well, this gives us the position of every pixel of an object that this script is attached to. So in our particular case, it's actually our sphere here, right? And so this position node here is going to say, hey, where is this position or the sphere in the world? Well, right now it's at 0, 1.14, and 0. And that's what this node is giving us. And move my little recorder out of the way here. All right, so now for our custom function, make sure that your graph inspector is open and you have these different options here. This is what opens up our custom world. And then this I here is what opens our graph inspector. Now, right now it's set the file, and we could just make a text file and have .hlsl and write this code in there and then just load it up through source. But we're going to go a little bit easier, and we're just going to have select string. Now, what string does is it just allows us to type the HLSL code inside of this box here. And I'm hoping that, we can zoom in on this so that it's not too hard for you to see on your laptop. Now we need to give this a custom function name, right? And I'm just going to name mine world position or world POS. And you'll notice when I click inside of here, we want to connect the output of our position node to this world position function here, right? So let's go ahead and do that. So in our outputs here, I'm going to actually copy this and I'm going to change it. I'm going to name it world position, and you'll see that I have a world position output. And then actually, let's make that an input. Sorry. So we're going to add an input here, and this input is going to be called world position. There we go. And on this world position node, what I can now do is I can actually connect this to here, but we're going to get a little bit of an error because we're using a float value here. And remember, with this, we're getting the X, Y, and Z, which is our current position. So you can go in here and change your world position to a vector 3. Now, in order to see, as we move our sphere around our scene, we want to get a color output, right? So with our world position, our custom function selected on our output here, I'm going to go ahead and create a new output method or output here variable. And we're just going to call this color out. And that's also going to be a vector 3. Now, the reason for this is if you look inside of here, you don't necessarily see a colored node. But you can represent any color with 3 values, right? The red, green, and blue value. And if you see any RGBA, A stands for the alpha value, this color out is going to actually give us, we can use this to output whatever the color value is of the world, right? So that's in our vector 3. Now inside of this box here, we can write some HLS, we can write our HLSL code to get the world position, right? And so let's go ahead and I'm going to change this name of this function. And what I'll do is, I'm going to type it so you don't have to watch me type it, and then I'm going to explain what each line does. All right, so the name here, my function name, is going to match the method that I type inside of here. And it's customary, depending on the studio you work for, where you type in, because this is, again, in a string value, it's built into here. You're going to write essentially what the data type of the parameter with an underscore there. You could very well at a studio be like, they just want you to name the function name of the code that you're going to write in here with just the name here. So what I mean by that is in a second, I'm going to type out what the actual function is. And all this is going to do is output the color of our variable, or it's going to output a color through this color out variable here onto a model. All right, so I went ahead and typed in the body of my HLSL code. And what's happening here is you want to think of these as sort of, this is our function name, and these are our parameters, right? We have an input parameter, which is world position, which I'm using here. So that's what's getting the position, our XYZ position here. And we have a color out here, which is what we're storing the color, this color out position, or this we're outputting a color that I'm going to feed right into my base color here. So I'm dragging that into my base color. So saturate, what that does is that gives us a value between 0 and 1. So what it's saying is, hey, whatever this world position is here, we're going to output that color, right? This X, Y, and Z color. And then the 0.1 just kind of helps us control the speed of that. So again, if this feels if it's still a little too confusing, don't worry about it. We're going to be diving in and doing this a lot, and you'll see a lot of repetitive code in the stuff that we're writing. So let me go ahead and double click this. I'm going to hit the save button here. And what you'll notice on our sphere is I select it, and as I'm moving this around, you can see it starts to change color depending on essentially our quadrant, right? Like if we're in a specific location. So let's go ahead and zero this out, 0, 0, 0, right? So this is the center. And I'm going to hit F to focus. And if we look at here, if our model is completely focused, centered, let me get rid of these guys so you can see this. Our model should have some sort of color that matches this, right? Where it's a green, a black, red, and yellow. So as I start to move on my x-axis, let's take a look at what's happening to our model here. Well, we're moving more towards that green area, right? And if I move on my y or my z-axis rather, I start to move down. You'll start that there's a color gradation. Now let's see what happens when we move to the right or the positive. You start to see it becoming more red, right? As we move into that quadrant. So we're moving from green to red here. Okay. What happens if we go on our y-axis here? Well, I'm going to go up. It starts to turn yellow. So this is matching the x, y, and z coordinates essentially, and it's just passing in the color value there of its world position. And that's all we're doing in this particular lesson. In the next video, we'll build on this, just kind of having fun again, building toon shaders and outlines and stuff.